Hello everyone, today I am going to deliver a lecture on welding induced distortion control and how to measure this welding induced distortion. In last class I have already started about the welding induced distortions. There I have discussed what is welding induced distortions and what are the different cause of welding induced distortion, and last class also I was discussing how to control the welding induced distortion. Some of the topics I discussed in last lecture. Today I will discuss some more related to welding induced distortion control related aspects. So, these are the some more important techniques by which we can control the welding induced distortion. Like here you can see, by offsetting the joint to be welded, the use of balance welding technique, the use of clamp, jig and fixtures, then stiffening by some stiffener, especially these types of stiffening types of distortion control technique is used in case of thin sheet, where generally some longitudinal stiffener is used to control the welding induced distortion. Then some other technique like thermal and mechanical tensioning, and another technique is heat sinking techniques. Apart from these things, I will discuss some other technique by which how to minimize or eliminate the welding induced distortion. So, these are the different aspects which I will discuss in detail in today's lecture. So, first of all I will discuss about offsetting the joint to be welded. So, by offsetting the joint to be welded, we can control the welding induced distortion significantly. Like once you do the welding, like this is a T joint. For T joint we know there is required to put some fillet weld here. So, what happens once this fillet weld zone shrink, then due to shrinkage its shape become like this. That is why here I have written angular distortion after weld. That means some angular shape is developed in the welded structure. So, we know after welding how the shape is coming, because as here you can see, as here the top side shrinkage force is more. Due to this, what happens, due to this top side shrinkage force, you can say let these types of top side shrinkage force with respect to neutral axis, you can say here the welding distortion is occur which is look like angle in nature. Here you can see. So, we know that once we do the welding in a T joint, then the shape will come like this. So, beforehand if we preset the member which will have some presetting angle, you can say, like I am showing in second figure, here you can see. So, if we just place the plate in opposite direction, like here you see, here after welding it is going upward direction. So, before welding if we just put it in downward direction like this, and after that if we just do the welding here and here, then due to the shrinkage force here, this plate will preset, or you can say it's return back to its original position, or you can say it's return back to its horizontal position. So, if we just preset the weld plate, and after that if we just do the welding, then what happens, we can due to this shrinkage force it's pull that plate, and what happens, due to this pulling action or shrinkage force action, the alignment can be what we want actually. So, that things only here it is written. So, several assembly can be preset out of position, that means here we preset the plate in out of position. After that generally we do the welding. Once we do the welding, once it cool, due to the shrinkage force it is returned back to its original position, or that means in horizontal position. So, here we can control the distortion significantly. So, this is one technique. Some other technique also here I am showing. So, like in a T joint, if we do one side welding, then what happens, due to one side welding there is a chance of here you see, if we do the one side welding, here this is a T, and if this T is in vertical position, and if we do the one side fillet welding like this, once this plate weld zone will shrink, due to this shrinkage force there is a chance of bending this flange, or you can say this vertical plate like this. So, to prevent this thing, if we just preset or offset this vertical plate like this, that means in other side, and after that if we just do the welding here, if we do the welding here, then due to the sinkage force this will return back to its vertical position. That means we actually we want, what I am telling, understand. So, this is another techniques by which we can control the distortion, like here I am showing. If we do the welding, here we get exact joint, and here the shape of the welded joint is not distorted type. Another techniques also, you know, that for butt welding we are offsetting the plate like this. What happens in case of butt welded joint, I have already discussed about this thing. The butt weld generally bit is look like this. So, it has some, you see, this is the neutral axis, you can say. So, above the neutral axis the volume of molten material is higher than below portion, you can say. Due to these things, above the neutral axis whatever the sinkage force is developed, let that sinkage force is F1, and below that whatever the sinkage force is developed, they let the sinkage force is F2. So, as the volume of this sinkage force is, you can say, proportional to volume of weld material, that means volume of molten weld material. So, what happens, as the top side volume of molten material is more than bottom side volume of molten material, that is why you can say here F1 is more than F2. Due to this unbalanced force, what happens, and more force at top side, the weld plate can bend like this. So, these are all angular types of distortion. So, we know that it will bend in upward direction. So, if we just preset this thing in downward direction like this, or offset the plate in this way here, which I am showing, you can see for butt welded joint. So, due to this, after that once we do the welding here, then due to this top sinkage force, then the plate will be aligned to appropriate position, what I am telling, understand, due to the sinkage force. So, it will be what we want actually, it will give us a shape what we want actually. Okay. That means it will be horizontal types of shape. Okay. So, this is one types of technique by which we can control the welding distortion. I will discuss another types of techniques, that is called balance welding techniques, or you can say by using different types of welding sequence also we can control the distortion significantly. So, some of the most widely applicable welding sequence here I am going to discuss, by which generally we can control the welding distortion significantly. Like one of the technique is called back step welding techniques or back step welding sequence technique. What does it means? In case of back step welding techniques, you can see here generally the welding is progress this direction, but what happens here you see. So, welding direction, you can say this is welding direction, gradually it is progressing in this direction, but we are starting the welding instead of at the end at some position, that means first weld pass will be this direction, second weld start from another location like this just after that, and its direction is opposite direction. So, this types of welding sequence technique name is back step welding techniques. So, this is third, this is fourth, but actually welding is progress in rightward direction, but welding sequence is done in left side direction, that you can see. Okay, this is first pass, this is second pass, this is third pass, this is fourth pass, this fourth pass in the sense fourth sequence. So, this way, so first you have to do the this portion of welding in this direction, then after that we instead of starting from this position, we have to start from this position, that means second position, then here, then here. Okay. So, once we do the welding like this, then what happens here, we can break the continuous types of welding sequence. So, in case of continuous types of welding sequence at a time, if we will do, there is a chance of more deformation and other things. So, once we do these types of what it is called back step types of welding sequence, then what happens, we can control the welding distortion significantly. Then another technique is called back skiff welding technique. So, here what is done here, first we do the welding first pass, after that second pass we used to do after skipping one step. You can see from this figure here, you can see that means first we do the first sequence here, then we skip one portion here, this, that means this third portion you can say. After that we used to do the welding this second, again this third, and after that this fourth. So, once we do the welding like this, then what happens, in between the welding portion can cool down, and this, as this length of this welding portion is comparatively less, which will not affect more in what it is called welding distortion. That is why what happens, these types of techniques, once we will follow during welding operation, we can control the welding distortion significantly. Some of the other techniques also here I am showing, which are popularly used, like this is called backward method. So, by backward method means, here you see, here the welding start from this side, okay, and it is go to rightward direction, then these. So, backward techniques and back step welding techniques are more or less same, you can say. Then another one is called symmetrical welding sequence method. So, in case of symmetrical welding sequence method, here you can see, so first generally welding is started from the middle portion, after that we goes to do the welding in outward direction, both side. So, why it is called symmetrical method? Because this first run start from middle, then second run right side of this first run, then third run is left side from this first run. So, right left, this way generally we used to do the welding here. So, as it is symmetrical with respect to mid section, or you can say middle portion, that is why these types of welding technique is called symmetrical method. Here you can see about this one sequence, this rest of the sequence is symmetrical in nature, what I am telling, understand. So, you see, by using these techniques we can significantly reduce the welding distortion. Here another things also you should keep it in mind, this is also a technique that is called welding start from center and progress outward direction. Center to outward direction types of welding sequence is very good for controlling both welding distortion as well as residual stress. This you should keep it in mind. Then a stepping stone method, this is a very interesting techniques. Here you can see stepping stone method means we skip one by one techniques. This stepping stone method you can say is like this. The stepping stone method is like here you see, this is the first pass, then we skip on this continuously this second portion, we start second term after skipping on a step, you can see this is second pass, then after that again we skip another step, this is third pass, then again we start this fourth sequence and then fifth sequence. So, this way this sequence, these are the sequence number I have provided. So, once we follow the welding sequence like this, then what happens, then we can control the welding distortion significantly. Another technique is called just forward method. Here you can say continuously we used to do the welding on a welded plate, like you see, this is first run, then second run, then third run, fourth sequence, then fifth sequence continuously, and it is generally welding direction and its sequence direction is also same. That is why it is called forward types of welding sequence method. So, by following these types of welding sequence method, generally these are the welding sequence method is SAS, which is also known as balanced types of welding sequence, because what happens is this one sequence generally balance the other sequence significant, by which generally we control both welding distortion as well as residual stress also significantly. Now, here I am going to discuss about the use of clamp, jig and fixture. By using this clamp, jig and fixtures, we can control the welding distortion. But here one thing you can keep it in mind, once we provide some jig or fixture or clamping types of device to hold the workpiece together, at that time generally we prevent the free movement of this expansion and contraction phenomena. So, once we restrict this expansion and contraction phenomena, then what happens, here there is a chance of developing internal residual stress significantly. That is why what happens, though here we are preventing actually this jig, fixture and clamps are such a device which generally used to hold the workpiece in required position, you can say. So, here generally we restrict the movement of the workpiece due to this expansion and contraction phenomena during welding process. So, that is why what happens here, we can control the distortion significantly, but due to non-movement, you can say, due to the restriction of the movement of the workpiece, here what happens, internally there is developed some locked in stress. So, here by using this types of holding device, what happens, the residual stress increase significantly, but what happens, by this we can control the distortion significantly. So, by using this clamp, jig and fixture, here we can control the distortion, but here the residual stress is increased, that things only here it is written. Here you see the main advantage of using jig and fixture or clamp is that it the element in a fabrication can be precisely located in the position to be welded, but its main disadvantage is generally due to this high level of residual stress is developed in welded structure. Here I am showing different types of fixture and jig. Here you see, here generally these types of fixtures we use to hold upward side of this welded plate. Here you see, this is the V groove of this bar joint, you can say. This is another types of fixture or jig, you can say. So, these types of fixtures, or you can say clamping device, we use back side of this welded plate. Here you can see. So, this is top sided types of holding device, this is back side type holding device, this is also back side type of holding device. So, these are the different types of holdings, jig or fixture we use to control the what is called weld induced distortion. Another techniques also generally we can use for controlling the distortion, that is called water cooled jig or water cooled types of fixture, you can say. So, in this holding device, what happens, this jig is generally cooled by some water channel inside this jig. Then what happens, due to this circulating water inside this jig, it generally take away the heat during welding operation. So, it reduce the heating effect in the welding zone. And now we know, higher the heat, higher the residual deformation, you can say, and higher the heat, higher the expansion contraction, and higher the residual deformation, that you can say. But what happens, once we use this water cooled types of jig, as it extracts some heat from this welding zone, that is why what happens is reduce the heating effect. Due to this reducing heating effect, what happens, here we can reduce the weld induced distortion. That is why water cooling types of or water cooled jig also popularly used, especially for thin sheet types of welded plate. Thin sheet types of welded plate, because what happens, in thin sheet types of welded plate there is a chance of more deformation. So, to restrict this deformation, generally what happens, sometimes this water cooled jig is used to control the weld induced distortion. Now, we will discuss about the tack welding. It is a ideal welding techniques for setting and maintaining the joint gap, but can also be used to restrict the transverse types of shrinkage. Now, first of all, we should know what is this tack weld. Tack weld means, here you see, tack weld means, let us we are going to join two workpiece together. This is one plate and this is another plate. So, tack weld generally used to align the workpiece together and to maintaining this root gap. Root gap means this gap between two workpiece. This is called generally gap between two workpiece, and in roadside generally whatever the gap is there, that is called root gap actually. This you should keep it in mind. So, generally to maintaining the gap, and because once this gap will be maintained properly, then what happens, your weld bit quality will be proper, and what happens, your weld joint quality also will be proper. Okay. That is why to maintaining the root gap and to fill the weld material properly in this joint region, this types of opening is required in between two workpiece. So, to maintaining this root gap, generally what happens, there is required to put some small welding, you can say, a small welding, just you can say spot types of welding generally we used to do within the entire length of this welded specimen, or welding specimen. Like this is one tack, this is another tack, this is another tack, okay, this is another tack. So, different tack generally we used to put like this, here you can see. So, you can say that tack weld is a small or a small weld length which we generally use to maintain the proper alignment of two workpiece and to maintain the root gap of this two workpiece, that you can say. Now, why it is required? This is required because what happens once we do the welding, once we start doing the welding from one side of a workpiece, then what happens, there is a chance of developing the, let's what happens here, we start the welding. So, once the welding progress, then this some of the portion of this welding starts solidifying, some of the portion of the welding will be in liquid state. So, whatever the portion is start solidifying, that portion generally creates some sinkage types of force. Due to this sinkage force, or you can say expansion force due to heating, that may, there is a chance of what, let this is the this is one workpiece, this is another workpiece. So, once we do the welding, start from one side, then there is a chance of bend this workpiece like this. That means it can overlap each other, or there is a chance of due to this force pattern, there is a chance to opening of this. So, one case there is a chance of closing of this root opening, or you can say closing of this gap, and there is another chance also due to this force pattern, there is a chance of opening of this. That means that gap can sometime it increase, or gap can sometime can decrease. That things here I have, that things is possible due to this heating and cooling effect, this means solidification effect, and you see melting effect of this workpiece material during welding process. Because in the once this weld material starts solidifying, there is develop some sinkage force. That sinkage force can affect the overall structures of this joint. You can say due to these things, sinkage force, or you can say expansion force, in one case there is a chance of closing that root gap, and in another case there is a chance of opening that root gap, correct. So, when these types of things can occur, when it can open and when it can close, that also you should know. Especially it is observed that in case of slow types of welding operation, in the sense slow welding operation, especially like manual metal arc welding process, then TIG welding process, which is generally done manually. In these types of welding process, what happens, whatever the means sinkage force system develop, that sinkage force system generally create the effect of this welding structure in such a way, due to this slow types of, you can say, due to this slow types of cooling or slow types of welding, there is a chance of what it is called, there is a chance of closing of this root gap. That means due to this sinkage force, it generally come together. This you can say. So, for slow types of welding process, these types of closing of root gap is generally occur. But in case of fast welding means, you can say fast types of welding. So, where generally there is a chance of opening of this root gap. Fast welding in the sense which is generally automatic in nature, especially in submerged types of arc welding process, where generally the deposition rate as it is very high in submerged arc welding process. That is why we can do the welding more faster way than manual metal arc welding process. That is why what happens, and as it is a automatic types of welding process and fast process, that is why in case of submerged arc welding, it is observed that there is a chance of opening that two workpiece. What I am telling, that means there is generally increase this root gap if this is not tacked properly. Okay. So, that is why to prevent this closing or opening of this root gap, this types of tacking is required. So, generally during tacking operation also we should follow some standard sequence. This also you should keep it in mind. Like here you see, here I am showing 3 different tacking sequence generally popularly used in welding operation, because during tacking also there is a chance of closing or opening of this root gap. To maintaining this root gap properly, we should follow some proper tacking sequence. Like here you see, first case I have shown that okay, tack weld straight through the end. Here this is first case, straight through the end means it start from 1, then it's second, then third, whatever the things I have shown, third, fourth, fifth, so fourth, fifth, sixth, seventh, so continuously we have to do the what it's called tack welding. We have to do the tack welding. Now this is called tack weld straight to the end, but in this types of tack welding technique, that means fast tack welding techniques, here what are the thing required to do? It is necessary to clamp the plate or to use wedges. Here you see to use wedges to maintaining the joint gap during tacking also, because once we continuously do the tack welding from one end to other end, then there is a chance of closing this root gap, or you can say gap between these two plates. So, to maintaining these things, we generally use some wedges. Wedges, what is wedges? Wedge generally is a wooden block, or you can say we generally insert this wedge, it can be wooden block, sometimes it can be metal block also. Generally wooden block is properly used as wedges. Okay. This wedge generally we use to maintaining the position properly, that you can say. So, generally in between this root gap, if we just insert a wooden block, after that if we just do the what it is called tacking, then due to this wooden block, whatever the sinkage force and other things will develop, that wooden block will prevent that sinkage effect or expansion effect. What I am telling, understand? That sinkage effect, you can say sinkage effect can be prevented. So, once we do continuous types of what you can say tack weld straight through to the end, then that types of case generally this wedge is required to use to prevent the closing of this root opening. Now, second case, here you see another tacking sequence you can follow, where you need not to use that types of wedge or clamp types of things before during tacking sequence. So, like here this second one is called tack weld one end and then use a back stepping technique. So, here you see, so we start tack weld one end like fast, this fast tack we do. So, after that generally we use back stepping types of technique. Back stepping types of technique I have already discussed in last slide itself, where generally welding direction and its what it is called welding progress direction is opposite to each other. Like here you see, you are going to do the tack in this direction, but you are doing the tack weld in other direction. Here you see 2, 3, then 4, 5, 6, 7. So, here you see this tacking direction is opposite, but progress of this tacking that means 1, 2, 3, 4 is other direction. That means one is forward direction and tacking weld direction is opposite direction. This you should keep it in mind. Now, by using these things we can control the this welding distortion also significantly. If we use the tacking, then what happens in the case of tacking, we can also control the what it is called transverse sinkage types of distortion. That is which I have written here in first point itself. How it is, that also I will just tell. Now, and third tacking sequence is generally tack weld the center and complete the tack weld by back stepping. So, here you see, here in this C diagram I am showing, that means this first we have to use the welding from the middle, that means we have to start the tack from the middle. After that you see this you can say symmetric types of tacking we are doing, then right side 2, left side 3, then right side 4, left side 5, right side 7, left side 6. So, this symmetric types of tacking once we will just use, by this also we can control the welding distortion, especially transverse types of shrinkage significantly by using these different types of tacking sequence. Now, this second and third tacking sequence you can avoid this what it is called wedges, but in fast welding tacking sequence, once you go for that means tack weld straight through the end, in that case you should use some wedge, otherwise your alignment will not be proper. Now, here you see how this transverse sinkage is restricted during this due to this tacking, that also you should know, because once you provide this tack, then what happens, it this tack generally resists the shrinkage effect during solidification of in that weld zone, because it generally maintaining this gap, okay. So, whatever the shrinkage force is try to happen in this welded plate due to solidification of this workpiece, So, due to this shrinkage force, if this tack will not be there, then we know there is a chance of shortening of the width of this weld plate like this. Okay. This is width of this weld plate. So, this generally this shortening of width of this weld plate is known as transverse shrinkage. Transverse shrinkage, correct. This is transverse shrinkage. Okay. So, transverse shrinkage generally will be restricted if we use this tack, because here generally this tack will prevent this shrinkage effect significantly. So, by this what happens, there is a chance of reduction of this welding what it is called welding transverse shrinkage significantly. This you should keep it in mind. Now, we can control the welding distortion by some other means also, like what happens if there is a workpiece, or you can say back to back assembly also can control the welding distortion significantly. Here what we used to do, here generally by tack weld or clamping two identical component, generally in case of two identical component, here we used to generally tack weld back to back. Here you can see in figure A I am showing. So, after that generally we have to do the welding, that means we have to put the stiffener like this, we have to do the welding in both side, here you see. So, after that we have to eliminate this tack from here, we have to eliminate this tack from here. So, what happens here, first of all before welding of this stiffener, these are all called stiffener. Generally this stiffener is used to put over the plate. Stiffener types of welding generally we used to do in case of plate to stiffen the plate. Okay. So, once we put the stiffener over the plate, then there is and once we do the welding to put this stiffener, then there is a chance of welding distortion significantly. To prevent this thing, generally before putting this stiffener, first of all we have to generally put this two identical component of this workpiece together by using some tacking. Here you see these are all tack types of welding. Okay. So, after that we have to generally put this stiffener by welding over the plate. So, after that one thing you should keep it in mind, before removing this tack from this two identical component, what are the things required to do? It is recommended that the assembly is stress relief before separating the components. So, after completion of this stiffener welding over the plate of this tack assembly, what are the things required to do? We have to do the stress relieving operation. After that, after stress relieving operation only, we have to eliminate this tack from there, and we have to separate this two component. Okay. By this we can significantly reduce the welding distortion. Okay. Now, if we will not do the stress relieving operation, for that case what we can do? So, instead of providing tack there, here what we can do? We have to just pre-stress these two identical workpiece, and you see both side we clamp together. In between generally instead of tacking, here we are providing some wedges, here you see. So, these wedges generally I have already told you what is wedge. So, this wedge generally put over there. After that generally we have to do the welding. Here you see these are the stiffener we are inserting over the plate to stiffen the plate. So, this is to put this stiffener over the plate, we have to do the welding, that is fillet welding generally we used to do. So, once we do the fillet welding here, then what happens, there is a chance of a very high distortion due to this shrinkage and expansion effect during and after welding process. So, to prevent these things, once we just clamp this workpiece together first, and in between if you just put this what it is called wedge, and after completion of welding, once we remove this wedge from there, then there is a chance of what happens, reduction of the welding distortion significantly. That things only here it is written. So, you see back to back assembly to control distortion when welding two identical component, like one is first figure showing assemblies tacked together before welding, and second case if you will not use tack, then use of wedges for component that distort on separation after welding. That means after welding, once we release this wedge and remove this clamp, then what happens, whatever the distortion and stress effect is developed inside this welded structure, that will release, and what happens here, the distortion control will be taken place significantly. That things here also it is written. It may be necessary to insert wedges between the component. So, when the wedges are removed, the part will move back to correct shape or alignment. Now, this is another technique by which generally we can control the distortion significantly. These types of technique especially used for thin sheet butt welded plate, you can say. Here this technique is called stiffening by longitudinal types of stiffener. What does it means? In case of thin sheet butt welding, what happens? There is a chance of longitudinal types of shrinkage due to this solidification effect of this weld bit. So, due to the solidification of this weld bit, there is a chance of that longitudinal types of shrinkage. Longitudinal types of shrinkage means shortening of the length of this weld specimen, that you can say. So, due to this longitudinal shrinkage force, what happens if the plate is thin in nature, then there is a chance of bowing effect, or you can say there is a chance of, that is bowing effect means due to this shrinkage force there is a chance of deformation of the plate like bow in nature. Bow types of shape can develop due to this longitudinal shrinkage. Now, to prevent this longitudinal shrinkage effect or to prevent this bowing, what are the things required to do? Before welding, we have to put some stiffener. You see, we have to put some stiffener over the plate. You see, which is longitudinal direction. Longitudinal direction means this is generally called longitudinal direction, longitudinal direction, and this generally perpendicular to the welding direction is called transverse direction. So, here you see this is on stiffener. This stiffener can be bar types of shape, or this can be angle types of shape, or this can be T shape. So, depending upon the requirement, it can be different types of shape of stiffener. There can be some valve shape of stiffener. What I am telling under the valve shape means the cross section of this stiffener is like this, valve in nature. The cross section of this stiffener can be T in nature. What I am telling understand? T in nature. This cross section of this here, whatever the stiffener I am showing in this figure, this is generally called angle shape, or you can say L shape stiffener. This stiffener generally we have to insert here. Here I have shown that this stiffener generally we have inserted before welding. After that we have to do the welding. So, once we do the welding after inserting this stiffener here, then this stiffener generally resists the shrinkage effect significantly. By this generally we can prevent the bowing effect in case of thin types of plate. Okay. But here one thing you should keep it in mind, we should insert this stiffener in such a location so that it should not interfere with welding. That means we should put this stiffener at a particular distance from this center of this weld line, so that it should not interfere during welding operation. It should not affect during welding operation. This you should keep it in mind. Now, some other technique like you see by generally doing thermal tensioning and mechanical tensioning. These are the very interesting and popular types of technique nowadays to prevent the welding distortion. Generally by this what are the things we used to do? By this generally we can control the welding distortion and what is called welding residual stress significantly. Like this tensioning process generally involve generating tensile stress at the weld zone. So, during welding either by mechanical tensioning or by imposing a preset temperature gradient in the weld zone, we can control the welding residual stress, side by side welding distortion significantly. Especially in mechanical types of tensioning, here generally the panel is first stressed mechanically. That means once we stress mechanically this panel, then what happens during welding operation there will be some tensile types of stress in welding zone itself. So, when the stressing load is released after welding, then the plate shrink and there is reduction in the amount of residual stress in plate, as well as there is a reduction in distortion also. So, in thermal tensioning what it does, in thermal tensioning also is a process which generally involves generating tensile stress at the weld zone before and during welding, and by imposing a preset temperature gradient. In case of thermal tensioning, here generally there is used a combination of heating and cooling elements to prevent the weld induced residual stress as well as distortion, or you can say to reduce the weld induced residual stress and distortion. So, you see, so this tensioning techniques is such a techniques where generally during and before welding itself we are providing some tensioning effect in the welding zone. So, what happens once there is a tension effect in welding zone and during generally after welding when it solidifies, during and after welding on its expansion and solidifying, then what happens due to this previous or you can say preset tensile effect, generally what happens, there is a chance of reducing this shrinkage effect significantly. What I am telling, understand, due to these things there is a chance of reduction of welding residual stress as well as welding distortion significantly, because after welding once we release this stress part from preset tensioning region, then what happens, it is pull back or return back to its original position and it release the residual stress as well as it release the is control the distortion significantly. Another technique is called heat sinking technique. A heat sinking technique is also very important techniques. Here what are the things we used to do? So, in case of heat sinking techniques, here also generally we cool the two workpiece by using some circulating water channel, like let us this is one workpiece, this is another workpiece. Okay. So, in between generally we are going to do the welding. So, what happens below this, just little bit away from this weld zone, below the workpiece, generally there is used some water circulation or water circulating system through which cool water is circulating. This is water actually, cool water. Okay. This cool water generally circulate below this workpiece. So, what it extract the heat from this weld zone. Due to this extracting heat from this weld zone, there is occur some less contraction types of effect. Due to this thing, what happens, there is generally occur some what it is called control of distortion. Okay. So, this is generally called heat sinking technique. Now, here you see this thermal tensioning and this mechanical tensioning. These two tensioning method generally is very popular. Always keep this thing in mind. In this technique generally we used to apply some tensile types of force in the weld zone during and before welding. This you should keep it in mind. So, after welding we release this tensile force. So, once we release the tensile force after welding, then what happens, it generally minimize this distortion as well as is minimize the residual stress. Generally this thermal tensioning can be categorized in two different categories. One is called transient thermal tensioning, here I am writing. One is called transient thermal tensioning, that is called TTT you can say. Another one is called static thermal tensioning. So, in case of just here I am just a little bit explaining how it is look like, then it will be more clear to you. This is called static thermal tensioning. What it is called? Static thermal tensioning. Little bit I am explaining, then it will be more clear to you. Thermal tensioning. And another one is called transient. This T represent transient thermal tensioning. So, in case of static thermal tensioning, how it occur? Let this is the weld line. So, just little away from this weld line, there is generally placed some resistance heater, or you can say resistance heating band. Resistance heating band generally here we use. This is called heating band or resistance heating band you can say. Okay. And just below this weld zone there is used some copper backing bar. So, this copper backing bar, in this copper backing bar there is a water channel, that means there is a drilled water channel, through that generally water is circulating. So, below this, just this is the weld line, this is the weld line, this is the weld line. So, below the weld line we use this copper backing bar for cooling purpose. These are all stationary, they generally preset over the weld plate. So, during and after welding generally we heat. So, here this heating vent, by this heating vent here generally we use a range of heating. That means this range of heating which can vary from 100 degree centigrade, then 200 degree centigrade, then 300 degree. So, different types of temperature range we have to heat in this region, and below this weld where there is a copper backing bar through which generally water is circulating. So, one is cooling effect we are providing, as well as at side there we are using some heating effect. Due to this cooling and heating effect during an welding operation there is occur some thermal tensioning, because due to this cooling effect, because there is occur some thermal gradient, you can say, that means heating and cooling effect, there is occur near the weld zone a thermal gradient. So, due to this thermal gradient in weld zone there we use generally some tensioning types of effect. So, due to this tensioning effect what happens, we can control the welding distortion and residual stress significantly. Okay, this is called static thermal tensioning. So, this is another case. Instead of generally in case of transient thermal tensioning, what happens here? Here generally we use the system of heating medium and you can say cooling medium during welding operation itself, which generally follow the welding path. That means which generally move with welding path. As it is moving with during welding process, which is not static in nature, that is why this is called transient thermal tensioning. So, in this case let us say here this is the weld torch, or you can say weld torch. So, just before this weld torch, both sides generally we use some cooling nozzle. This is generally cooling nozzle, you can say cooling nozzle, which generally cool this weld portion. So, ahead of this weld torch there we use some heating torch, or you can say this heating torch. So, this is called generally transient thermal tensioning. So, you see ahead of the weld torch, or you can say welding position, there is a heating effect. Just behind of this heating torch there is a cooling nozzle, that is there is a cooling effect. By using these things what we can do, we can create some tensioning effect in the weld zone. So, by applying this tensioning effect we can control the welding distortion and residual stress significantly. This is some very important techniques here I am showing, by which we can control the welding distortion significantly. Like if you see what I have already told you, generally to stiffen the bare plate we generally put some stiffener over the plate to stiffen the plate. Okay, this is you see, this is one stiffener, this is another stiffener, this is another stiffener. Now what happens, this stiffener, once we do the welding continuously, means through the this stiffener left side right side, once we do the welding continuously, so without stopping anywhere, then this due to this continuous types of flat weld, once we do, then the welding deformation taken place which is significantly very high. Now this stiffener also we can place, instead of doing continuous weld plate, we can just do some intermittent types of fillet weld. Intermittent types of fillet weld, what does it means? Here one thing you should keep it in mind. So, let this is a plate, over this we are putting this stiffener. So, let this is the cross sectional view of this plate and stiffener, you see. So, here we are doing fillet weld. This is called fillet weld. You are well familiar what is fillet weld, what is butt weld. So, I am not going in details here. So, intermittent weld means instead of doing continuous welding, some portion of the plate we have to do welding, after that we have to put some gap. That means here we are breaking the continuous welding process. So, this is generally this types of welding means instead of continuous welding, here we generally breaking that continuity here, and we are doing the welding after providing some gap and gap. This types of welding is generally called intermittent welding. So, once we put this stiffener over the plate, by using this intermittent types of welding, by using this intermittent welding we can stiffen the plate, but here as the welding volume of material, or you can say weld length is less, heat is less, due to this there will occur less shrinkage force. So, due to this less shrinkage force, definitely there will be less deformation. So, instead of continuous weld, if we just do intermittent types of weld, then what happens, there we can reduce the distortion significantly. But always keep this thing in mind, if it is not watertight or airtight types of structure, there it is okay, intermittent types of welding, but where there is required watertight or airtight, there generally continuous types of welding is required. Or instead of using this intermittent welding, if we use some other technique, that is called slot weld, or you can say 3-plate weld. 3-plate weld if we will do, then what happens, that way also we can further reduce the welding deformation. What I am telling, what is this slot weld? What is this slot weld? Means slot weld means, let us here you see, this is the plate, this is the plate. So, first of all I will just discuss about slot weld. So, what happens, this is the plate, below this stiffener we have to put. So, this slot weld means here we have to make a slot, means by we have to remove some portion of this plate material. After that we have to generally fill this portion. Once we put the material in this slot, then this weld material will generally weld this stiffener with the plate. These types of means by making slot, if we do the welding, there we can significantly control the welding distortion. Apart from this slot welding, another way also we can put the stiffener, like there is generally instead of single plate, here we can use 2 plate. Over this 2 plate we can put the stiffener like that. After that we can do the welding. After that we can do the welding. So, if we just that is called 3-plate weld, that is called 3-plate weld. So, if we just do the 3-plate weld like this, that means 3 separate plate together and weld in that joining region, by this also we can significantly reduce the welding distortion. This you should keep it in mind. Now, let us, in a welded structure already there is occur some welding distortion. So, this distorted welding structure, how we can eliminate or minimize this deformation shape, that is called correction of distorted weldment. So, there are different way, and you can say means of correcting the distortion by using following method. Like you see, we can correct this weld induced distortion by using some mechanical means or by using some thermal method. Generally in mechanical means, like there we can in distorted portion we can press, or we can do some pinning types of operation. That pinning operation is generally by hammering backside of this hammer. Then what happens, we can reduce that deformation shape, okay, by using some jack screw, because then the distorted portion, by applying jack screw and by screw we can press that distorted portion, we can control the or minimize the distortion over there. We can use some straightening techniques, we can use roller, we can use sledge types of instrument to control the distortion. We can use some special types of fixtures. These special types of fixtures generally can use to control the means minimize the distortion or eliminate the distortion. We can provide some spot compression also. That means where there is a distortion in that position, we can provide some spot types of compression, and after that we can minimize the distortion over there. We can control the or correct the distortion by some thermal method also. Thermal method means in that distorted portion, if we just heat, then what happens, there will occur some expansion and contraction types of phenomena, by which generally we can control the deformation significant. That is why what happens, thermal method is also popularly used. There can be oxyacetylene types of torch, then there can be carbon arc, there can be powerful oil or gas types of burner, there can be some spot heating, hot straightening techniques, there can be some thermal stress relief technique, or flame straightening types of technique. These are the different types of techniques which generally used to correct the distorted weldment. This you should keep it in mind. This thermal stress relief means here this technique generally is a control heating of this distorted plate and control cooling. That means control heating with some elevated temperature. After that, once we do the control cooling, then there is occur stress relief, simultaneously control the or minimize the distortion. So, different types of techniques we can use to correct this distorted weldment. Okay. So, these are the following references which I followed for this lectures. Thank you.